Okay, in 4.7, we have something called the principle of transmissibility. Let's think of this like this. Suppose I have a bar here, and I apply force over here, parallel with the bar. Well, I could come down here and sketch this bar again. Let's keep it blue. And put our force back in. What I could do is I could come over here to B, and I could essentially add zero force by adding minus F, same magnitude as this, and plus F, same magnitude as that. And we'll see that this minus F cancels with that positive F, and I'm left with F over here. So what this says is essentially what you can do is you can move a force if it's along the same line of action anywhere in your body, and the same effect occurs. So after cancellation, it'll look the same. Let's go back to this, and here we have a situation now like this, where the force is at B, and has the same effect on this thing. Exact same effect. Okay, so that's the same line of action. So this is for forces along same line of action. But we can also do something similar for forces in general. So let's get our blue shape going again. So this time, we don't need to make it so long. This time we have our shape here. Let me copy it. And I have a force now right here. Notice this is perpendicular to our shape, or the direction I want to head, and I have point B and point A. So if I'm going to move this force to B, then I can do that. But if I do that, there's a little extra thing I have to take into account. So I can move, go with different colors again. I can go with a minus F and a plus F over here. And notice that these two cancel again. But since this was a perpendicular force, it also causes a moment here. So I need to add that in. So I've got to have the moment about B equals our force times whatever this distance is, perpendicular distance. So that's what I'm left with, a force and a moment. We can do this with systems. Of forces. And free moments. So say I have this blob with these forces and this free moment. I could then do the same thing. I can pick an arbitrary point. Let's say O. Then I can string up position vectors to both of these. I could then slide each of these forces here. This one's pointing in this direction. This is a free moment. I can slide it anywhere in here. So I'll slide it here also. And then this force and distance produces a moment. So it looks like it's heading in somewhere like, I guess it points down. Somewhere like this direction. Moment due to 1 about O. And this guy and this R also produce a moment about O. Looks like it's in somewhere something like this direction. Moment due to 2 about O. And then now I can just come up with my resultants. First off, I'll have a resultant force. Looks like it's heading somewhere up this direction. It didn't work. And then these 3 moments add together for a resultant moment. Maybe it's heading in this direction. And those are my resultants. So for an example, let's this is example 4-104. Let's replace this system of forces by a resultant force couple system at O. So first off, let's sum forces in the x direction. And I need to make an adjustment here. These are all along this line. So if we then have minus 150 times 4/5 plus 300 cosine of 30 plus 200. This is going to equal 339.81 pounds. And I'll just put an arrow on it so we know. Summing our forces in our y direction. So I can move all those down to O. In the y direction, nothing there. We have positive here. So 150 times 3/5. Positive there, plus 300 sine of 30 degrees. And this is going to equal 240 pounds, heading up in this direction. So our resultant equals 3, let's just do 340 pounds, I plus 240 pounds J. Okay, drawing a little picture here. So we got FR that's heading, actually it's not heading in the Y direction. It heads this way. Now we don't have any free moments, but we do have moments here. So sum of moments about O of these forces. And I'm just going to do this as a scalar. It's going to be easier in this situation. So let's see. I have 200 times 2 feet, and that's causing a minus. I have 150 times 4/5, and that is times 4 feet. That'll be this one here, this component here. Then I have a component up here in this direction. So minus 300 cosine of 30 degrees. And I almost always forget to put on my moment arm. This is going to equal minus 1478.85 foot-pounds, or 1479 negative. It's going to be in this direction. So this will occur over here. That's it.